everyone, so we are going to be working on 4-6 today, which is formalizing relations and functions. It sounds way more complicated than it really is. So our first page is all definitions and just a sentence that you need to fill in the blanks for. So it's just definitions that you really need, and you should have had this before. So domain of a function means all of the possible input values. So every x value that this domain has, that this function has. Range is all of the output values. So all of those y values that the relation has. So then a relation is the pairing of numbers in domain with numbers in the range. So it's just basically like those coordinate points, and it creates a relation. So a function is a special type of relation in which each value in the domain is paired with exactly one value in the range. So we'll get into what that means a little bit more, and I'll show you what that actually is talking about, but you have to know that relation is a big umbrella term and a function is a special type of a relation. Okay? So the first thing that we're going to do is, it says that we're going to identify the domain and range of each relation, and it wants us to represent the relation with a mapping diagram, and then it wants us to know, is the relation a function? So the domain is, I'm just going to call this D, and I'm going to call this R because I don't have too much space. So the domain is, all of our possible x values. So our x values are these first numbers in our coordinate points. So our domain is -2, 0, 4, and 5. And the way that you can write that is this, that domain, and then a nice squiggly bracket, and then you're going to list all of those values. -2, 0, 4, 5. And they don't need to be in any particular order. I just kind of write it how they are. So then our range is all of those y values that correspond. So we have we have 0.5, we have 2.5, we have 6.5, and then again we have 2.5, and I'm not going to write it again. So our range is those three values. So 0.5, 2.5, and 6.5. Okay? So the mapping diagram, all it does is it points arrows to the domain that matches up with the range. So -2 goes with 0.5, 0 goes with 2.5, 4 goes with 6.5, and 5 goes with 2.5. And we need to establish, is this a function or is it a relation? So, well, we know that functions are relations, but is it a function? So the criteria for a function is that I need to make sure that all of these x values go to a different y value. So, for example, -2 only goes to 5, so we're good. 0 only goes to 2.5, so we're good. 4 only goes to 6.5, so we're good, and 5 only goes to 2.5, so we're good. So you can't have domain that goes to more than one value in the range. So this is a function. Okay? Over here, we're going to do the same thing. So our domain, again, is all of those x values. So we have 6, this is our domain, we have 6, 4, we have 6 again, so I'm not going to write it, and then we have 5. So our domain is 6, 4, and 5. Now our range is all the y values. So we have 5, 3, 4, and 8. That should be an 8. Okay? So we can write this in order, or you can write it however it is. Doesn't matter. So we have 5, 3, 4, and 8. And now I'm going to use this diagram mapping, to see if it's a relation, to see if it's a function, I'm sorry. So 6 maps to 5, 4 maps to 3, 6 matches to 4, and 5 matches to 8. So if I take a look at this, I see that 6 goes to 2 different values in the range. So therefore, this is not a function. Do you see the difference? This is not a function because this x value goes to two different y values, whereas all of these x values only go to one y value. Okay? So, there's another way that we are able to figure out if a relation is a function or not, and it's called the vertical line test. So vertical line, again, is a straight up and down line, and what it says is that if this vertical line passes through the graph at more than one point, it is not a function. So we're going to take a look at number one. So we see all of these points. So I just want to take a quick look. What I want to do is draw vertical lines straight down through all of these points and see what we get. So this second line right here crosses through 2 points, right? Therefore, it is not a function. Not a function. Now, the reason for that, we're going to connect it back. So this 1 point was negative 1, 1, right? Negative 1, 1. The other point down here is negative 1, negative 1. And didn't we say on the last page that the same x value could not go to two different y values? Well, that's what's happening right here. Therefore, it's not a function. So it's doing the same thing. It's just a visual representation of what is not a function and what is. So number two, if I draw straight lines through, everywhere I draw, it's only hitting 1 point. Therefore, it is a function. Same thing over here. If I draw straight lines, straight vertical lines through all of these points on my line, I know I'm only hitting 1 point for each line. So again, this is a function. Okay? Okay. So usually we see equations using x and y equals something with x in it, but the same notation can be written, the same equation can be written in a different notation, and it's called function notation. So our y is replaced by f of x. We see this right here. So it means the same thing, it's just easier for us to find the answers to some problems. So here we're going to evaluate a function. So it says that the function w of x equals 250x. And that represents the number of words, which is w of x, that you can read in x minutes. How many words can you read in 8 minutes? So x is representing minutes. So what I want to do is take this function and plug in 8 for x. So w of 8 equals 250 times x, which is 8. So w of 8 equals, let's see what we get. We get, when you multiply these two numbers together, you get 2,000. So what that means is that you can read 2,000 words in 8 minutes. So it's just another way of substituting in an x value into a function that's just in a function notation instead. So last up, we have this function. It says f of x equals negative 1.5x plus 4. And it says that the domain of that function, so our domain up here, is 1, 2, 3, and 4. And it wants us to figure out what the range is. So domain, we figured out on the first page where the definitions were that domain is all of our input values. So our range is all of our output values. So what I'm going to do is we are going to input all of these values and figure out what our outputs are, and our outputs create our range. So f of 1 equals negative 1.5 times 1 plus 4. When we multiply negative 1.5 times 1, we get 1.5. We get negative 1.5 plus 4, and we end up with 2.5. Down here, we get negative 1.5 times 2 plus 4. Negative 1.5 times 2 is negative 3 plus 4, which gives us 1. Negative 1.5 times 3 plus 4. Negative 1.5 times 3 is negative 4.5 plus 4, which is 1/2, 0.5. And lastly, negative 1.5 times 4, that gives us, plus 4. So that gives us 6. Negative 6 plus 4, which is a negative 2. That should be a negative 0.5. So these are all of our outputs, these numbers on the right-hand side here. So that becomes our range. So I can write that our range is 2.5, 1, negative 0.5, and negative 2. And there you go. So I want you to try that one on your own. The next one, it says that the domain of the function f of x equals 4x minus 12, and the domain of that is 1, 3, 5, and 7, and it wants to figure out what the range is. So set it up the same way I did, substitute those domains in, and figure out what your outputs are. Nice job, guys. Have a great night.